Okay, hello everyone, and happy Friday. I'm not feeling well, as I mentioned to some of you yesterday, and so I am going to be out for the day. But fortunately for you, your learning can continue, so I'm sure you're all excited about that. So anyway, just kind of wanted to review what we did yesterday. Basically, we did the interpolation between logarithmic functions and logarithmic equations and what we call exponential equations. And if you remember, basically what we have down here, this little subscript is our base, which appears right here when we convert from logarithmic to exponential. This number that's out here is our exponent, and then this number is what we're going to have things equal to. So if we have the logarithm in base 2 of 16 equals 4, we can rewrite that as 2 to the 4th equals 16. And then the reverse of that, and this one's a little hard to see, if we have 5 to the second power equals 25, we can rewrite that as the logarithm in base 5 of 25 equals 2. Okay? What we want to do now is we want to look at first how do we evaluate logarithmic expressions. And by evaluate, we mean figure out what this is equal to. So we need to figure out this portion of it. And our second part is we're going to talk about what we can do on our calculator. So first things first, let's evaluate each of these logarithms. So when I'm looking at this first problem that says the logarithm in base 4 of 64, realistically what I'm asking is I'm saying 4 to what power equals 64? And so you either know that or you don't know it. And if you don't know it, that's fine because you have your calculators and you can do a couple of things. You can just basically guess and check. Well, let's see here. 4 raised to the second power. No, that's 16, not 64. So 4 raised to the third power, that is 64. So we know that 4 raised to the third power is 64. So if we go back to the original problem, we can say the logarithm of base 4 equals of 64 equals 3. Okay, and that's what we're looking for our answer of 3. Okay, now some nuances to that. If we have the logarithm in base 5 of 0.2, the first thing I would do is I would get rid of that 0.2 and I would rewrite it as a fraction. Okay, 0.2 is 1/5 as a fraction, and now you can see we've got a 5 here and a 5 here. So we're looking at 5 to what power equals 1/5, and that's kind of like this problem up here. Okay, all right, so where we had basically we're saying 1/4 to what power equals 4, and that's -1. Well, here we got kind of the reverse. So 5 to what power equals 1/5? You can do it one of two ways. You can either, if you know that those are reciprocals, and so you have a -1 as an answer, that's fine. But if you're unsure, remember that hint that we talked about yesterday. Since 5 is bigger than 1/5, or better yet, we have a fraction where it's 1/5, we can just kind of guess and check. So 5 raised to the -1, and we get our 0.2. Okay, so remember that hint, if we have a fraction of 1 over something, we know we're going to have a negative exponent. All right, similarly, what if we have this one here, we're asking for 1/5 to what power equals 125? Okay, my initial guess is that it's kind of like this problem here. Not quite the same, but a little bit different. So my hint would be maybe work with some negative exponents. So I'm going to go ahead and take my 1/5 power, or excuse me, my 1/5 fraction, and I don't know, I'm going to take it to the -2. Well, that's good. That gets me closer to 125, but I'm not quite there. And so what I can do is I can just retry that, and instead of -2, I'm going to put -3, and lo and behold. Okay, so if you're working between fractions, converting this to a large number, we should know that we have to take our fraction to a negative exponent. Oh, by the way, that's a typo. That equal sign shouldn't be there. So we know this is going to be -3, so we know our answer is -3. Okay? And now this one is kind of like this one right here. Basically, we're saying 36 to what power equals 6. And we talked about that if you're going from a larger base to a smaller number, you're probably going to have fractional exponents. And if you think about it, 36, the square root of 36 equals 6. And what's the square root as a fractional exponent? Hopefully you remember that it's 1/2. So 36 raised to the 1/2, and we get an answer of 6. So that means that 36 to the 1/2 is our exponent. So the logarithm in base 36 of 6 is 1/2. Okay? So that's how you evaluate them. You're looking for the exponent that makes the exponential expression or the exponential equation true. Okay? This other part's really cool. We talked a little bit about it yesterday. If we don't have a number here, like up here we had a 4 as our base, 5 as our base, 1/5 as our base. If we don't have a number, we can assume that the base is going to be 10, and we don't have to write the 10 in there. Okay, whoops, log base 10 of 10,000. Remember what this is asking for. This is asking for 10 to what power equals 10,000. Now this one you could probably use a little bit of logic and say it's going to be 4, but you can also do it on your calculator. And to do logarithms on your calculator, key thing, base 10, what we call the common logarithm. Okay, common log. We can do it in our calculator. So we type logarithm of 10,000, and let's see what we get. As you can see, we get an answer of 4. So this answer is going to be 4. That's the answer we're looking for. Excuse me. Now the cool thing about the common logarithm is that we can do any number. So if I want to do the logarithm of 87, that's obviously not going to come out even. I know it's going to be somewhere between 1 and 2 because 10 to the first power is 10, but 10 to the second power is going to be 100. And 87 falls between 10 and 100. So all we got to do, log 87, bam, 1.9395. I'm going to take out a few decimal places, 1.9395. And what that means, if I take 10 raised to the 1.9395, this is going to be, this right here is going to be really close to 87. It'll be a little off because we rounded, and look at that. Okay. We can also do what's called the natural logarithm. And if you remember E, remember the number E from last week, which is 2.71828. Okay, the calculator can do what's called the natural logarithm, and all the natural logarithm is a logarithm with a base e, and we call that the natural logarithm. Natural log. So anytime you have e in your equation, instead of doing the logarithm, we want to do the natural log. Okay, and once again, we can do that on the calculator. So if we do ln of e, right there, okay, e to the 5th, whoops, that won't work. Let me delete that. You got to bump out here and now close it off. Look what happens. We get an answer of 5, okay? Because look what we're doing with logarithms and now natural logarithms. We're looking for exponents. So shortcut, if I have ln e to the 5th, hey, I just know it's that exponent, and I get an answer of 5. And just like this one right here, you can do the natural logarithm of any number, ln of 92, natural log of 92, 4.5218. So 4.5218. And here's what's cool about that, just to verify, if I take e raised to the 4.5218, I should get around 92. Why do I keep doing that? And you can see I get a little more than 92 because we rounded up. Okay? All right, well, that's your Friday lesson. Hope you have a good weekend. Finish off that exit ticket, and let's hope for no homework for you for over the weekend. Review on Monday. Tuesday, a little bit more review.